guys, we are going to look at surface areas of pyramids and cones today. So we've dealt with surface area in last lecture, and we looked at cylinders and prisms. So today we're going to look at pyramids and cones. Let's recall the definition of a pyramid is a polyhedron with a polygon base and triangular lateral faces. Okay. Since our polygon base is a square, I'm going to have 4 of those congruent triangular lateral faces. Let's see. We know that this is the base, and this base happens to be either a square or a rectangle. We don't know that for sure. We also have the lateral face. We have 4 lateral faces because I have 4 sides on my base. This is my lateral face, so it's going to be this triangular. What we're going to take a look at today is what's called a slant height. The slant height is the height of this slanted triangle, because all of these are tipped or slanted inward so they can meet at this vertex. The slant height is the lateral height. It's the perpendicular from the vertex to the base of the lateral side. That piece is called the slant height. It is the height of lateral face. The slant height usually designated with a cursive baby L, lowercase l. We also are going to have a height, so the figure height, the height between the vertex to the base of the pyramid. So perpendicular from the vertex was going to go right straight down the middle of this pyramid, land right in the middle of my base at a right angle. That is the height or the altitude of the whole figure. So you got to be careful if you're looking for the figure height or the slant height when we start working on these. And then where all our lateral faces meet is called the vertex. If we take a look at this pyramid as a net, we can see we have our base. All of these bases, unless told otherwise, are going to be regular polygons. So they're going to be equal, lateral, or regular, all sides congruent. And then we can fold out each triangle like a flower, and we're going to have a lateral face, so we'd have 4 lateral faces. The height of each of these faces is perpendicular from its vertex to the base, so that's the slant height. And then the figure height goes right through the middle of the 3-dimensional figure. So let's take a look at the theorems or the formulas for these. The lateral area, like we learned in the last lecture, is just the area of each of the triangles. Since I have a pyramid times the height, and I have a base times a 1/2 base times height, and then I have another 1/2 base times height, and another 1/2 base times height, and another 1/2 base times height. We can put that all into one lateral formula. So the lateral area, remember, without base, and surface area is all faces, including the base. So the formula for lateral area for this is going to be 1/2. Sometimes you'll see it as a capital P, sometimes it's lowercase, and then a curvy L, which is my slant height. So P in this case is perimeter, like we learned yesterday, of the base. So it's not perimeter of the lateral piece, it's the perimeter of the base. And this cursive lowercase l is your slant height. So you got to be careful with which pieces you need to pull together. So that's going to give me the lateral area. That's going to give me all 4 of these because I'm multiplying by the perimeter. So there's 4 of those. So whatever the length that perimeter is, that means I'm going to be taking all of that area. And then we also have the surface area. So surface area, basically speaking, and I think on your Ames reference sheet, talks about big B, which is your base area plus your lateral area. So B is base area, and LA we already know is lateral area. So we can substitute in for my lateral area. We already know it's defined as 1/2 the whole perimeter of the base times the slant height. So let's take a look at these. So find the lateral area of a regular square pyramid. So I know it's a square pyramid. They're all going to be regular. When I'm doing these, I'm going to tell you guys over and over and over that you need to start with the formula that applies. So I'm looking for lateral area of a pyramid, so I'm going to use the lateral area formula. Then go and find and substitute in the pieces that you know. I know that my lateral area, P, stands for the perimeter of the base. So I need to figure out what the perimeter of the base is. Perimeter, since it's regular square, all of these are going to be congruent. So I know this base, baby B, the base of just one lateral face is 90, but I have 4 of those, so I'm going to substitute in 90 times 4. I also know that the cursive L is my slant height. That's the slant height here. That's the slanted. It's still perpendicular to its base, but it's slanted inward toward the pyramid. I got to figure out what that height is. Right now, all I have is the figure's height, not just the lateral height. So I have a height here. Since I know the side length is here, I know I go from the center of the base over to the side. That's going to chop my side length in half. So half of my base side, since it's a regular polygon, my height will always drop and cut in my side in half. So I end up with this right triangle of 45, 97, and my slant height. So my slant height is the hypotenuse. So in order to substitute in my L, I got to go figure out what my slant height is. So I know I have a right triangle. I have 2 sides of a right triangle. I should use the Pythagorean theorem. So over here on the side, I'm going to do L squared is equal to, my hypotenuse is equal to the sum of the squares of the other sides. So I know it's equal to, what are these other sides? 97 squared plus 45 squared. We're not approximating anything yet. We don't approximate until the very end. So I know L is equal to the square root of 97 squared plus 45 squared in my calculator is 11,434. Square root of. So now that I know what that is, I can go and substitute it into my formula that I previously wrote down. 11,434. Sometimes it'll say exact, so we should approximate. We should simplify this and see if anything comes out of that. But since we're looking at approximate right now, we're going to put this 1/2 times 90 times 4 times the square root of 11,434 into our calculators, and we'll get approximately 19,247.4 centimeters squared. Start with the formula, then substitute in the pieces. If you need to go find what these pieces are, go over to the side and find out what your missing pieces are. All right, let's try another one. We're going to find the surface area of a regular hexagonal pyramid. So I know I've got pyramids. I'm going to go find my formula for pyramid. Hexagonal just means I have 6 sides, all which are congruent. Surface area. So surface area means I have the big B, which is the base area, since I only have 1, plus my lateral area. Base area plus the lateral area is 1/2 perimeter times the slant height. And I need to go figure out the base. The base area for a regular hexagon is 1/2 apothem times the perimeter. Oops. So right now I'm just setting up the formula to make sure I have all the pieces correct. Don't skip these steps. You're going to regret it if you do. Then I go figure out the pieces I have. So 1/2, baby A is apothem. So they broke the base out for us so we could see it in a little more detail. Apothem is from the center perpendicular to the side, so I know my apothem is 4 rad 3. P is perimeter, 8, 1, 2, 3, 4, 5, 6. So 8 times 6 equals 48. That's going to be my perimeter, which will come in handy when we go to do the lateral area, side 2. Plus 1/2 P again is my perimeter of the base. And now all I need is my slant height. So go back to my original. Lucky for us, they already told us our slant height. We don't need to go find it using Pythagorean theorem. So we know the slant height is 18. Substitute in the pieces, simplify, and then go from there. We always want to start with an exact if we can. So I'm going to 1/2 times 4 times 48. That's going to give me 48 times 2, which is 96 rad 3. Half of 48, 24 times 18, that's going to give me 432. That is an exact answer. And I put it in my calculator and get approximately 598.3 inches squared. As we discussed in class, these have a lot more steps, but they're the same steps that we used last unit when we were just looking for area. You've got to find your pieces and be able to substitute them in. You have a couple of U-tries that you're going to do. I am going to show all the steps. I don't want you copying them down. Make sure you try them and then go back and follow the steps if you need to. But you should pause the video and try them so that you can make sure you know what you're doing. Okay, there are your worked out solutions. Don't just copy. It doesn't do you any good. Make sure you go back and actually try to get these on your own. Let me know if you have any questions when you get to class tomorrow. Alright, last figure you want to take a look at is the cone. The definition of a cone is a figure with circular base and vertex not on base. Because it can be an oblique cone. So I could have my vertex over here and it be slanted and I still have a height perpendicular and a slant height, and off I go. But usually you're going to see something that looks like this. So on your cone, from the center of the cone, which happens to be the center of the circle, to the side would be your radius. From there up to the vertex is going to be your altitude, also known as your height. And this slant height, because this forms a right triangle, the slanted hypotenuse piece becomes your slant height, which is your lowercase cursive l. And then the circle area itself in entirety is the base. So it's the same sort of concept as it was with the pyramid. The lateral area is going to equal, since we're dealing with lateral, this is all this outside stuff, 1/2 times the circumference around it, 2 pi r, times the slant height. But we know 1/2 times 2 is just 1, so I could rewrite this as lateral area equals pi r l. We also have a surface area. That means I take the base area, so big B is base area, plus the lateral area. The base area, it's a circle, so the area of a circle is pi r squared. And the lateral area of a cone is pi r l. So identifying your pieces and setting them up, that's all there is to cones. So let's take a look at, we are in a chemistry lab, and you use this conical filter, a funnel, and it's going to funnel down whatever you're filtering through. But along the inside of this funnel, we have some filter paper. So there's some really thin filter paper hanging out inside here. The paper is not going to go across our funnel, so I'm looking just for the lateral area because the paper is going to sit in there along the edges of my cone. So I know I need the lateral area. The lateral area for a cone is pi r l. And then I just substitute and find the pieces I know. So pi r, the whole way across is my diameter, so my r, or radius, is going to be 40. And then I have to find my slant height. So I go over here. Remember, slant height is the hypotenuse of the right triangle that is formed with your other height. So right now they gave me height is 45. I know half of a diameter is the radius, which is 45. So I end up with a right triangle that has 45 height of 40, half of 80 is 40, get the math right, with a height of 45. And my slant height then is going to be the hypotenuse. So over on the side, in order to figure out L, I'm going to do L is equal to the square root. So normally square root of L squared is equal to 45 squared plus 40 squared. So I'm skipping a step and going automatically to knowing that L is going to be the square root of 40 squared plus 45 squared. So 40 squared plus 45 squared in my calculator is 3625. And we're going to practice simplifying that radical. And I'm going to go, since it ends in 5, the easiest one is to start with 5 because it's prime number. 5 times 7, 25. I have another 5, so I can divide by 5 again. 5 times 145. I have another 5, so I should divide by 5, and I end up with 29. 29 is a prime number, so 29 times 1 is where I end up. So I can simplify the square root of 3,625 as 5, because I have a pair of 5s, and then I got to multiply what I have left over. 5 times 29, which got me back up to 145. So if it had asked you for the exact, I would take this L that I just found, substitute it in here, 5 rad 145. And I get 40 times 5, which is 200. The rad 145 comes along for the ride, and there's still pi in there, millimeters squared. That's my exact answer, which is approximately in my calculator. Watch your rounding on this, because if we round to the nearest tenth, you get 7565.9, blah, blah, something like that. Well, 9 is going to round up to 10, which means the 5 is going to round up to 6, so approximately 7,566 millimeters squared. So those are my 2 correct answers there. Okay, you're going to try the next couple. Watch what it's looking for. Make sure you start with the formula and then substitute it in. Come back and check your answers. All right, there are your answers. I will see you in class.